This is my first meetup as a presenter or like as a speaker. So I thought of doing this way back, but due to some commitments, we were never able to find a slot. So I have been working in IT industry from around 3.5 years, and all of it is completely on MuleSoft itself. And apart from coding, I like math a lot. If probably I was not an engineer, I would have become a maths professor. But also, have represented my state in cricket, so under 16 cricket. So after that, I could not uh, pursue that professionally. But I'm a cricket enthusiast as well. So we can get started. So the topic for today is basically Kafka with Mule 4. Like when we say Kafka, like Kafka in general, there are different types of Kafka, but today we'll be talking about Apache Kafka, which is like an open source software which we can use to integrate with the Mule. So we do not need any license for this basically. So going on. So I will be talking about like what is Kafka in general for people who have not, been in touch for this, and how we can use or integrate Apache Kafka in Mule 4. What are the common connectors which we find in our particular Kafka from the exchange? Like what are the connector operations we find for Apache Kafka? And also some important terms related to Kafka, what we need to understand, and also demo. And basically, at the last, uh, we'll just talk about the design consideration. So, whenever you're designing a Kafka application, what are the things which you have to basically consider while designing, especially in Mule 4? So, that is something which we'll talk about. So, moving on to what is Kafka. So, Kafka is basically it's a pub sub model. So I think everyone would understand what is a pub sub model is. So it's basically a publisher subscriber model, and Kafka is known for its volume handling capabilities. So as you can see, it can handle trillions of events in a day, depending on how we design it. Uh, the volume is never a problem for the actual Kafka backend to handle. So it all comes down to how we design to leverage the advantages of Kafka and handle many events a day. So Kafka was actually developed by LinkedIn, and then it was made open source in 2011. And mainly, what are the usage of Kafka? Like it's mainly used in real-time data pipelines. So whenever we need a structure where the updates has to be done on a real-time basis, we use Kafka a lot in that particular scenario. And also, it's vastly used in data analytics. So let's say there is some user operation which is happening on a particular website. So and you need to build a data like analytic dashboard out of it. So Kafka is a very good tool for that. So basically, you can send the messages through the Kafka and consume and do your analysis part. And also, it enables easy connection to non-mule applications using the REST API. So this is something which we'll not cover today, but technically we can connect to the Kafka backend with the REST API. But this is not something which we do today. Kafka designs focus on high throughput, low latency, making it suitable for real-time data processing. I think we already covered that. So mostly it's used in real-time events. And also based on what type of Kafka you're using, we can have statistics and also a very good UI where we can actually capture the messages and the throughput of the messages and like which consumer is consuming how many messages, like where each topic is. So we'll talk about the consumers and topic in the subsequent slides. So this is generally about what is Kafka. Just give me. I'm sorry. Just give me 1 minute. Sorry.
I think there's some emergency. Just a minute, he'll be back.
In meanwhile, maybe anyone has used Apache Kafka in their project? Just checking. Or maybe you have any question related to the MuleSoft, you can also ask.
I just had a question related to the next meetup, like you were just mentioning, right? In the Salesforce office, Bangalore.
Yeah, so we have like more than 100 attendees, and also like 150 people are waiting.
Yeah. So,
And we have limited capacity of 100 people only.
no
And yeah,
problem.
and we have sent one like who is confirmed. We have sent one Google form for further confirmation. So if you have received it, then please fill it out. And also like one more meetup we have, like Mysore is conducting meetup in Bangalore. So maybe you can join that one also. That is on 10th of August. I think there will be no restriction for attendees count there.
Okay, and even that's in Salesforce office itself.
No, no, no. That is in LTI Whitefield.
Oh, okay, got it. I guess Guru is back.
Okay, sorry guys. Actually, I am in the middle of some emergency, so I had to conclude the call. So moving on to our slide. Yeah, so currently there are two types of Kafka. One is Apache Kafka, which is open source, right? And then there is Confluence Kafka. So Confluent Kafka is something which Confluent is a company. Basically, they made Kafka. Actually, Kafka is open source, so they utilize the Kafka, and you have a very good UI when you have to use Confluent Kafka, and even the setup process becomes very easy. So Confluent Kafka is like we would say it's like a paid version of the Kafka. But if you are gonna use something which is open source and you just have to maintain by yourself, Apache Kafka is the a very good like option for POCs, and also if you are if the project budget is very tight, we can go with Apache Kafka. And also apart from this, we have a Kafka service from Amazon. It's called as AMSK, and also from Azure and Google also. So these are like other three major paid Kafka, what to say, providers, service providers. All of them provides a equally good UI. So depending on the pricing, people will go for whichever is fitting in their particular budget. I have used AMSK, so in my previous project. So this is the types of Kafka, I would say. And now we will talk about Kafka architecture. So whenever, like in Kafka in general, it's consisting of three main things: the Kafka cluster, where the Kafka servers reside, and a publisher. A publisher is a separate would say a separate a computer or separate server which will basically produce or write the messages into the particular topics. So topic is something like it's analogous to a queue. So if you have worked with Amazon SQS queue or Anypoint MQ, a topic is something which is analogous to that. And consumer is, as the name suggests, is the server which basically consumes the data. So as you can see here, we have something called as partitions, right? So partitions are nothing but in. So let's say we have a queue. in our Amazon SQS or any sort of queuing service, right? So a queue it might be a FIFO queue. That means first in, first out, and you have to consume the messages one after the another. But when it comes to topic, what happens is each topic is broken down into partitions. So it can have one partition at the least, and it can have n number of partitions. So the maximum which I have worked with is three. So a topic is actually broken down into a number of different segments, which is called partitions, and this partition can be anywhere within the Kafka cluster. It does not like it's not mandatory that each partition has to reside in the same server. It can be split into multiple servers as well. And consumers, when it comes to consumers, we can have a number of consumers. Each consumer group might have any number of consumers basically. So if the number of consumers is equal to number of partitions, then each consumer will read from individual topic. If you see this consumer group B, uh, consumer 3 is reading from consumer 0, consumer 4 is reading from partition 3, consumer 5 is reading from partition 1, and consumer 6 is reading from partition 2. When it comes to consumer group A, here we have two consumers. So here what's happening, it's being split. So one consumer will read from two partition, another consumer will read from the rest of the two partitions. And one good thing about Kafka is consumer group A and consumer group B are completely independent. That means whenever consumer A consumes a message, the same message is also available for consumption in consumer B. So where this comes in handy is, so let's say you have a user operation. Out of it, you have to create a data analytics dashboard, and also you have to maintain some sort of count or enter into a database. So what we can do is we'll utilize the same topic. You will have one consumer to do the data analytics part and another consumer to do the data operation part. So basically the DB operation part. So the data is written once, but it can be read by multiple consumer groups. So that's one of the that's the reason why Kafka is used in most real time events or real time architecture. And so as I was talking about a Kafka topic, right? So each Kafka topic can have n number of partitions, and within each partition, each message is stored within ID, and that ID will call it as offset. So it goes from 0 to n. So the numbering of the message offset goes to 0 to n. So where do we need this offset is so this will get to a later part. So we'll see that in the demo what this offset does basically, right? So as you can see, a topic may contain any number of partition and messages are written to topic, and Kafka randomly select which partition to write. So if from the consumer publisher side, we are not specifying which partition to write into, uh, in that case, what happens is the broker, so the Kafka broker within the cluster, it decides, which partition the data has to be written into. So sometimes we can specify which partition it has to be written, and if we do not need that at random, it will go into any partition as decided by the Kafka broker, basically. And 0 is the first offset, and n is the newest offset. So whenever we talk about the latest message, it is always the last uncommitted offset of that particular partition. So we will talk about what is a commit operation in the next slides. So here we'll just get an overview of what are Kafka components. So I think producers and consumers, I don't have to explain that much. Producers and consumers are basically, producers write the message into the topic and consumers just read the message from a topic. And what is topic? So topic is basically analogous to a queue, but not entirely analogous, because here the data is written split down into partitions. So they are basically a channel where message resides and where the message propagates. And partition. So as I said, partitions are nothing but bifurcation or the data which is split into different segments. So we don't lose data basically. So partitions is also very good when it comes to reliability. Whenever we have a Kafka downtime, partitions can be, we can have multiple partitions, and there are a lot of things which we can do when you want to write to specific partitions. and also brokers. So brokers are something, but they are the Kafka servers. They are the ones who manage and store the data. So let's say a message is coming. So if the particular partition is not mentioned in the producer side, brokers are the one which decides, which partition to which we have to write to basically. And also there are multiple consumer groups. So there might be different set of APIs which are reading data from the same topic. In that case, a broker actually knows. So which API is basically, has read to what offset of each particular topic. So brokers are some, we can say it's a server on its own which manages the reading and writing of the data. Replication. So replication here is what replication means is, let's say we have a topic and a topic has three partitions, and if the replication factor is 3, then all those partitions, there two other replicas will be created for that. So basically we have a redundant storage of the same message. So whenever a data is written, it is written into the original partitions as well, and also to the redundant partitions. So that's where the replication comes from. Even replication is for the case of disaster recovery. If the data is lost, we can get the data from a different replica. So the data is not lost basically. And consumer group. So as you know, consumer groups, we can have n number of consumer groups. It's a group of consumers, and it is ideal to have the same number of consumers within a consumer group, which is equal to the partition. So let's say a Kafka topic has three partitions. In that case, ideally, we have to use three consumers in the consumer group. Even if you use more than that, that's fine. It will not make any problem. Even if you use less than that, that is also fine. But ideal scenario, we should have the number of consumers in a consumer group should not be beyond the number of partition in that particular topic. On offset. So an offset is a unique identifier for which each message within a partition. So it keeps track of the position of the consumer in the partition. So for this, let me just go back to this particular example. So let's assume we have two consumer groups, and both of them are the same Kafka topic, right? So a consumer group would have just read until offset 4, and the next consumer group would have read until offset 6. So the broker knows which consumer group has read message till which offset. So whenever the consumer becomes active, so it will know which offset it should start reading messages from. So basically whenever a consumer consumes the message, it commits back. So there is something called as a commit operation. It sends back the offset to the broker. So the broker knows what is the last read message. So for some reason, if the consumer stops consuming and it starts consuming after that, it will immediately start from the next offset basically. So if it has read till 3, it will start from 4. And this is for all the partitions, not just one, but for all the partitions. So offset is very much useful when we have multiple consumers, and especially if we need to identify a particular data, we can do that. Kafka components we are done. So we'll just go through the advantages of Kafka. So high throughput and performance. So personally, I have written code where we handled 1 million records in a day. So 1 million records is not small. And as you can see if it is designed properly, it can handle large amounts of data events. Scalable architecture. So let's say we have the amount of Kafka brokers are not like it's not working for us in the particular design. We can scale that particular Kafka architecture. We can increase the number of brokers and servers and also the partitions. But one downside to partition is that in some cases, if you want to change the number of partitions, you have to delete the entire topic and do it again. But in technical terms, the brokers or servers where the partitions are held, it's easily scalable. So if the particular server does not have enough what to say processing capability, we can increase the capacity of that particular broker to handle more data. Durability and persistence. So persistence, as the name suggests, a data written into Kafka is never truly deleted. It's a false, it's a pseudo statement we can say, because at the end we can delete the data, we have something called as data retention. So usually the data retention might be 7 days, 15 days, or 30 days. It's up to us what we want to decide. But it's not as in queues, right? So let's say we purge a queue, that data is lost. So in terms of that, the data is actually persistent, and it's also durable. So throughout its persistence, we can access any offset and any data within any topic. And fault tolerance and reliability. So as you know, if there is a consumer, or if a consumer fails, we know exactly from where we can read the data again. So in case of faults, we can easily read the data again, so the data is not lost. So real-time data processing, so as it's a fire and forget kind of a thing, in real we can use it for real-time data processing. Decoupling data stream. So what this means is producers, brokers, and consumers are independent basically. So producer is not dependent on the consumer. Consumer is not directly dependent on the producer, because we have a middle broker layer here. Stream processing capabilities. We can also stream the data, and that's one of the big advantages. If in the case where we have data which is like, and there is a limit of 1 MB. So currently in Apache Kafka and even in MuleSoft, we cannot push a data which is greater than 1 MB. But major use cases which I have seen is like data will not go beyond like 250 KB or something. Exactly one semantics. So whenever you have like normal queues or normal async operations, there might be a risk of rereading the same message. So there might be some requirements where the message should not be read twice. In that case, Kafka comes in at a really good pace, because we can design it in such a way that each message is read only once, and that is to one single consumer group. But if it has multiple consumer groups, all can read the same message. But when it comes to one singular set of consumer groups, we can make sure that our consumer is reading the message only once, because we have the commit operation, right? Now create client application token. So this is something which is outside for the discussion, so we can leave this now. Rich ecosystem and integration. So as I said, we have an open source of Kafka and also multiple providers of Kafka. So the ecosystem is really good if you want to go into it, and it's we can say it's analogous to MuleSoft, because whatever error you find in MuleSoft, right? You just Google it. There is a MuleSoft help link for that. So the ecosystem is really good, and efficient storage management. So even the storage of this can be managed very efficiently, especially if you are using a distributed version of Kafka, which is like Confident Kafka. It gives you a lot of tools where you can manage the storage, and flexible deployment option. So if you are going with your own Kafka server, you can also deploy it on your own bare metal, and also you can deploy it on cloud. So there are a lot of deployment options here, and it's cost effective. So considering the subscription plans and subscription prices of other things, if we have enough resources to use the open source Kafka, then it's very cost effective, and strong community support. And many people and many organizations use Kafka, so there is a very strong community, to support if there is any errors. So moving on.
Couple of questions, maybe we can.
Okay, sure.
So first question is from Vivek Gupta. What is the
Mhm.
benefit of the partitions?
Okay, so that's a good question. So let's say, so for this we have to compare this with an SQS queue. Okay, so let's say you have is one single channel or a queue, and it's not Kafka, right? So let's assume that the same data has to be used for two different things, and that's not possible, because once you read the data for that particular operation and it's done, you cannot reuse it. Now what's the advantage here is, so let's say we have three partitions, and while writing the data, we can actually specify to which partition we can write the data, and from consumer side as well, we can mention from which particular partition it has to read. So while writing data into a single topic, you can actually create three consumers, and you can do three different configurations or three different processes within the same topic. So that's the advantage of the partitions. And another main advantage is that the data is not stored in one server, because partition means it's partitioned into different servers, right? And if you have multiple replication factors for it, data is not technically lost. That's the main advantage. And are there any other questions?
Yeah, again related to partition only. Two more
Mhm.
questions. How one gets to know about number of partitions in the Kafka cluster?
Okay, so if we are creating the Kafka topic on our own, that is something which we have to decide. And these things will not know. I mean, if you have a UI, you will know that from there. Because I have worked with Amazon Kafka and AMSK. There in the UI it says each topic, how many consumers are there, how many consumer groups are there, and what are the offsets, right? And also what are the number of partitions. So those are something which is already in the UI part. But while creating topic only, we will actually have to decide all these things: the name of the topic, the retention period, the number of partition, and also the replication factor. So these are all the four things which we would have to decide beforehand. Are there message groups available in Kafka? What do you mean by message groups, Vivek? Can you elaborate on that?
So we have another question like, so how is topic dividing the data into different partitions? Like what is the partition at strategy?
What is partition?
Strategy.
Oh, sorry, is it in the Q&A section?
No, no, no. In the chat.
Okay, just a second.
Before Vivek Gupta, there is one more question.
Okay, how one gets to know? Okay, so how topic is dividing data into different parts? Like what is the partition strategy? So I am not sure about the partition strategy, but I assume it's mostly round robin. And this is something which is maintained at the broker end. So this is something which you do not have control on. So whenever you do not specify to what partition you want to write it, it is usually the broker which decides, and there might be multiple strategies there. And I think usually it's round robin, but it also depends on various other factors. Currently, I cannot recall actually. And Vivek, I'm not sure about the message groups actually. I only know of the consumer groups, but I'm not sure. Probably consumer groups is same as message groups, but I might be wrong. I'm not sure of that. Cool. So moving on with the, can we move on to the yeah, connector operations. So connector operations. So these are all the types of connector operations which we have in Apache Kafka connector for MuleSoft. So we have a publish, consume, commit, message listener, batch message listener, and seek. So we'll go through all of this in the demo. So let's move on to demo. So I will just let me share my screen again. Yeah. Okay, I'll share the entire screen. Okay. So hope you can see my screen.
Yes.
Cool. Okay. Okay. So
Guru, one second.
before this,
Can
yes.
you just increase the font or the screen size? I feel somehow it is small.
Okay. Just okay. I don't think so. I can do that because I'm using the secondary monitor.
No, the attendees can do one thing. They can right click on their screen. You will get an option of show all controls. And at the bottom left corner, you will get an option to full screen.
Thanks, Abhishek. Yeah, attendees can do that.
All right. Sorry, guys. I'm using a monitor, so probably that's the reason. And as it's the secondary screen only, there is no option to scale it. So before going into this, there are a couple of I just quickly want to show you how to download Kafka and install Kafka. So it's a pretty straightforward basically. So you can just Google download Kafka, right? And it opens the Apache Kafka page. And from here you can download the scalar 2.13 or 2.12, and it just gives out a zip file basically. And once you have the zip file, you can extract it to, I would prefer the C folder, but it doesn't matter. Sometimes if you go to inside or any folders, sometimes the deployments will fail. So I always suggest that do it in the C folder. And once you have it, there are a couple of changes which we have to do for once we have done it. So the prerequisite for this is it requires Java and Maven, of course. So if you have Anypoint Studio running, Java and Maven is already installed. So I don't think that's a matter. So when you install it, the structure looks something like this. And a couple of changes which we have to do is we have to open the config. Sorry, not config. This is bin Windows. No, yes. I think there is property file. Yeah. Let me see. I think it's in the config. Yeah. So you have zookeeper.properties. You have to make a change there. So when you open the zookeeper.properties, there is a default data directory. So you just have to give earlier it will be just tmp/zookeeper. We just have to change this. So zookeeper is nothing but it's a broker for Apache Kafka. So it does the brokering job here. And also server properties. Even here we have to make a change. And here also for log.directories, we have to give this particular. And this is a folder name where the logs are stored. I just renamed it to Kafka.logs. And by default, it uses port 2181 localhost, but translating that to MuleSoft, it's actually 9092. So even you can play around with this port as well. So these are something which you have to do. And once you have it, we will move on to connector configuration. So you can just download the Anypoint Apache Kafka connector from the exchange. And as you can see, you have a publish, consume, message listener, batch message listener, commit, and seek. So these are the 6 operations which you have. So moving on to producer part, here the configuration. So when it comes to configurations, here we have like 2 configurations mainly. One is the producer configuration and another is the consumer configuration. So let's click on producer configuration. So there are some things which are common for both producer and consumer configuration. One is that the connection type. So as I am running it in the local, I'm using plain text connection. But you have SSL plain, SSL scram, SSL token, auth, and so many other types basically. And work with SSL scram when connecting to the Amazon AMSK instance. So in that case, we use the SSL scram connection, but here it's plain connection because this is local. And here we have to give a bootstrap server. On what is the server at which the Kafka is running? So the 2181 port there translates to 9092. So this is 9092 where our Kafka server is running. So first thing first, we have to actually start the zookeeper and then start the Kafka server. So these are the commands. Zookeeper start that bat, and we just use these properties to start the zookeeper, and it looks something like this. So zookeeper is already started, right? Then other part is we have to start the Kafka. So it's similar. We have a command for that, and it starts the Kafka. And at the end, there is this another. This is to create a. This command is particularly to create a topic. So I am creating topic where replication factor is 3, partitions is 1, and the topic name is meetup.batch. Meetup batch. I also have another topics which is just meetup. So these are the things. So these you can easily find it online, these commands. So that's not another issue. So I'll quickly cover the producer and consumer configuration. So producer is pretty straightforward. You just have to give the server and the server URL. And when it comes to TLS, right? So we do not need a TLS when it is a local host. But when you are connecting to a distributed server like Amazon MSK or any other provider, There we have to actually use, there is one change which we have to do. So in the trust store, the type has to be JKS. So this mostly establishes connection, in a very secure format, considering that your Kafka is in a private space, basically. So this should mostly work with all types of consumers, but all types of Kafka providers. But we do not require this in the local. So I'm just canceling that. Next, we'll go to consumer configuration. So this will take a little time because there are a lot of things to cover here. So please pay attention. So first thing first is it's the same thing. We have the connection type, we have the Bootstrap server URL, and here the topic. So this is the actual topic name. So this configuration is a topic where I'm just utilizing it for a single listener demo. So I just named it as meetup. Now the actual things come in the advanced tab. Okay. So in advanced tab, you have a boatload of configurations which you can maintain. To find the optimal value, it will take a lot of time. It depends on what is the load which we are using, what is the load we are expecting for our APIs. So based on that, all these particular things has to be decided. For example, in our previous project, to get the optimum value for these all configuration, it took us around 2 months of testing. So because if everything is new, if you don't have a baseline of understanding of how this works, and if you're running it for the very first time, each of this configuration mean a different thing, and to our sweet spot of all your configuration, it will take some testing. So I'll just go through few important stuff. I cannot cover all today, but I'll go through some important stuff. So fetch minimum size. So what is the minimum size of the data which you want to fetch, right? So by default, we have 1 byte and maximum limit is 1 MB. And the minimum and maximum sizes is something which we can set here. Is there a question? Okay. Yeah, Zookeeper is kind of obsolete, I would say, but for local, that's the only option because that's the only source option we can. Different connections we have in producer configuration. Oh, actually, I've used only two: SSL Scram and plaintext connection. The rest I have not used. It depends on how it is set up in the backend, so I do not have that information. Sorry. Okay, so here whenever we are consuming so in our case it's a listener or a batch message listener, we can set the limits of how much data which it has to retrieve basically. So the defaults are like 1 byte and maximum is 1 MB, but of course we can play around with this. And default maximum partition fetch size. So let's say you have multiple partitions, and what is the maximum to fetch? So even that minimum and maximum limit is something which you, and the wait timeout is basically how much time it has to wait before actually a successful way consume operation has been done. And acknowledgement mode. So when it comes to acknowledgement mode, we have like 4, and I have used only 3. Dupes, okay, I have not used it. So auto is something that whenever the particular flow where we have the batch message listener or an individual message listener, when it is working fine without any errors, it will commit back the offset to the broker, right? So that is auto. And immediate is something that as soon as the message listener listens to the message, it commit back the offset. It does not matter whether the flow is successful or not. So immediate, I would not suggest it, because if you immediately commit the offset back and that message has failed, then in that case you cannot basically not read it again. I mean, you can read it, but you have to go through a different set of operations to set back the offset of that particular consumer to the last unread thing, right? So immediate is not usually recommended. Manual will go through it. So manual is that we get the consumer commit key of that particular message offset, and we manually commit it back. So that is something we will go through the demo. Okay. So for now, it's auto in this particular thing, but these are actually overridden to what you do in the flow. So and in flow level, we can change it, and flow always takes precedence. And yeah, heartbeat interval. So heartbeat interval is something which we have to basically consider, and this value has to be tested depending on our load. So heartbeat interval is nothing but whenever a consumer group is subscribed to a particular topic, each consumer group will be sending back a signal to the broker by which the broker knows the message is still the consumer is active. So sometimes what happens if the heartbeat interval is not set properly, while consuming data, the consumer might stop consuming because of this heartbeat, and this heartbeat is like a continuous process. So whenever the app is running, it continuously pings the broker back. So this heartbeat interval is something which you wanna after a lot of testing we have to come at a particular value. And there was another thing which I have to talk about, which was record limit. So this record limit is something which we use in the batch message listener. So batch is kind of a we have two types of limits for batch here. So while reading the batch, doing the batch demo, I'll come back to that. Yeah, and polling interval. So polling interval is how often do you want to poll for new messages. And here it's the default, but when in the flow level, we can actually set these values, right? And so let's just quickly test the connection. If our server is working, test connection has to be successful. It might not work because the app is already running, but I think we're already connected. Yeah, test connection is successful. All right, so let's go back. So here is the publish operation. So we'll start with a single publish and consume operation, right? Sorry, single publish and single message listener operation. So as you can see here, we can say what is the topic, what partition we have to go write it to, and what is the key. So this key is nothing but in some UIs, right? We can apart from offset, we can set a value from which we can identify the whole message. So in most of the cases, this key can be like an ID in that particular any unique ID the message has. We can set the key for that, so that we can just type the unique ID and we get the messages. So we can filter by the keys from the UI. So this key is something only for like testing purposes or UI purposes, right? And headers. So apart from the payload, you can also pass the headers. So this is a simple publish operation. So here's what we'll do. We'll just go through a demo, right? So I'll just publish it. So let me add a breakpoint. Yeah. And actually, this is we are writing to a meetup particular topic, which is a single message topic which I am using, and I am using the Apache Kafka consumer configuration, which is pointing to meetup, right? And here the acknowledgement mode is manual. So we will know what is a manual commit now. So let's just trigger it. Yeah. So once we have published this, we'll wait for the data to come here. Oh, probably I did not add this breakpoint here. Let me add it. So before I add a breakpoint, you can see the console. Whatever the headers I'm sending, I got the headers, and it's also telling me what is the offset of my message. So I did some testing in the morning. So for this particular topic, whatever message we wrote was on the, and I have only one partition. So this is the 29th message. So 29 is the offset of the message which you have written. And key, as I said, whatever we set the key as, you'll just set the value. And we have a creation timestamp and also the topic. Now let's go back and see it in real time. So I'm triggering it now. So I'll just publish it. Again, I did the same mistake. Sorry. Let me add a breakpoint. But you can see the offset has increased it to 30. Hope you guys are getting my point. Yeah, you got the message. So in this transform message, I'm just transforming the payload and attribute so that we can see the data. So this is the message which you are publishing from the postman headers and all the things which you just discussed about. And also here you have something called as consumer commit key. So this consumer commit key is the key which we have to send back to the broker. So for this particular offset message, this is the commit key. So in commit operation, what we are doing is we'll just send back that consumer commit key. So the broker knows this particular consumer has read until offset 31. So this is a manual commit operation. We'll just finish this. So now let's try a auto commit basically. What I'll be doing is I'll change the commit mode to auto. In that case, we do not require a manual commit operation. I'll just toggle this off. So let me just save this. Let it redeploy. Okay, it will take some time. It's not building automatically. Let me debug it. Meanwhile, are there any questions? Okay, I see a couple of them. No, polling is something a consumer basically at what time, like at what intervals have to check for messages. Heartbeat is something the broker knows that the consumer is is active. So it's kind of different. They're not same. So how does data element look like in Kafka? It is headers, key, payload, timestamp. Akhil, what exactly do you mean by that? Can you elaborate? Okay, meanwhile you type that, we'll go back. And this deployment will take some time, guys, because it depends on how many partitions have. Sometimes it takes, depending on how many partitions we are subscribing to, it checks which, like each topic and stuff. So deployment takes a little time.
Pratik, there's one more question from Hariharan.
Okay, come back.
Yeah.
Please explain the difference between message listener and consumer operation. Okay, consumer operation, we actually have a demo for that. We'll go cover that. So message listener, I mean, at a high level, message listener is something like it acts as a source. Okay. So that means whenever a new message comes up, it will automatically trigger that flow. It's like a HTTP listener. It's a source. It creates or triggers the event. Consume operation is something that you don't want to read the message as soon as it's there, but whenever a HTTP listener is triggered or a flow is triggered, at that time you have to read the message. So consume operation is something similar. If you have worked with endpoint MQ, I think there you have a consume operation. So it's similar to that. What type of data can be sent to topics? Text, message, PDF, binary. The thing is, no problem, Hari. I have worked with JSON, but I am sure that it also works with other types of data as well. But I have just worked with JSON and XML. I have not worked with the other, so I am not 100% confident on the answer I'm giving. But I think it should work with all the formats as long as we can stream the data. Okay, moving back. Okay, it's still deploying. Probably it's because the load on my system has increased. I'm already sharing the screen, so let's give it some time. Meanwhile, I'm open for questions if you have anything or anything in particular you have to discuss about Kafka. Meanwhile, that my code flies. Okay, no more questions, I guess. Can we see same message getting consumer multiple consumer now outside etc. works there? Yeah, of course we can do that, but not at this moment because when we're using a distributed version of Kafka in the UI you can see. So let's say you have same message or same topic subscribed for 4 different APIs, and each API has one consumer group. So there we can see what is the latest offset each consumer group is having. So that's technically possible, but only when you have a paid version where you have an UI for that. In local, I think there's a way to see that, but I have not explored that part actually. Can the Confluent Kafka also be utilized with the same connector? I don't think so. I don't think so. For Confluent, we already have a connector. Confluent for Confluent Kafka itself, we have a connector. I think we can use that. Uh, yeah. Okay. All right. Yeah, it's deployed. So now we will just trigger it. We'll just let me change the data. Hello. Okay. Yeah. As you can see, offset is 32. We still get a consumer commit key, but the lizard automatically, once the flow completes, it will commit it back. We don't have to actually commit it. So that is an example of a single message listener. Now moving on to batch message listener, right? So batch message listener is something where you can listen to messages in batches. So let's say you only want first 5 MB of the data which comes in, or you need first 10 or 15 records which comes in. So this is like it will. So what the message listener does is it accumulates all the data and it'll just push it as one particular array. The output will be an array which we can basically use, right? So that's the only difference between batch message listener and message listener. If you tweak it properly, even batch message listener can work as a individual message listener, but that's not recommended. And so we have some design consideration when we are using batch message listeners from my personal experience. So that we'll cover in the later slide, but we'll just test out the batch publish. So here what I'm doing, I'm publishing 30 messages basically. So I have an array of 30 and I'm just, the message is hello max, and I'm just appending the like the 1 2 the index of the array. So we'll just trigger that and we'll see how that works. And we have a batch message listener here, so we'll just go through this. So the poll timeout is 1 second. We can, it's actually polling for messages every second. So is there anything else? No. Okay. So let me trigger it. So I'm just triggering that particular. So let me just complete this. So it has published 30 messages. So now we can see. So I have a logger here. So it will give me the size of payload. Okay. So how much data it's using. So let's see. In the first run, it has received 10 records. In the next run, it's 1 record. 10 again. Any guess what it will be now? Any guesses? How many records it will get now? We published 30, right? So how much will be left? Okay, no answer. That's fine. It's 9 because we published 30. So where is this 10 coming from? Anything less than 10 is fine, but it's not going beyond 10. Why is that? So for that, we'll just go through the configuration once. So this is the batch configuration. Okay. So advanced record size. Where is the record size? Default record limit. Sorry. So I have a record limit of 10 records. That means how much ever incoming messages are there, I just want it not more than 10. It should give me like 10 particular messages at once. So that is where this record limit comes like. There is also another option which we can do. So let's say we know the exact size of the data which we are sending. Let's assume the data which we are sending is 10 KB, right? And you need to process 1 MB of data. So what we can do is the maximum limit of the data we can set it to 1 MB, and then it will accumulate. Sorry, the minimum should be 1 MB. So until 1 MB is consumed, it will not even trigger the listener. Max is something different. So until that fetch minimum size is satisfied, it will not create an event basically. So these two are mutually exclusive. The fetch minimum size and the record limit is something which are mutually exclusive. If the record limit is hit first, it will give that much number of messages. And if the data is accumulating to 1 MB, then it will come up to 1 MB of that many records might come. So it does not always say that, so these are mutually exclusive. And I think this is kind of a drawback. If we can pool it with the number of records or number of size separately, that would have been a much greater flexibility in design. But this is something which I feel is kind of a drawback here. So these two are mutually exclusive. So either it will wait for the record limit to hit or the size limit to hit. And why are we getting only one record? Because the fetch minimum size is partition size is 1 KB or something. So whenever it's reaching that, so I'm getting that. So it does not always wait till 10. If you have data, it will get that one also. But if it has a bunch of 10 records, it will trigger an event in that case. Hope I am actually not confusing you guys, but this is listener, batch message listener. Before we move on to seek and consume, any questions? Oh, 9. Yeah, that's correct. How to order messages based on some payload attribute. Order the messages. Are you talking in terms of consumption or like in what sense? Vivek? Sequencing of messages. No, sequence is always based on offset. So sequencing always based on offset. So that is something sequencing I think you can do if you had like specifically specifying to what partition you have to write data. That you can do, but usually it's based on offset only. If suppose there are 4 consumers for same message, if it fails for one consumer and a key is at true for all, then the message remains in topic. Yeah. So what's happening is to talk at a very high level. If you have only if you have 4 consumers for one topic, so this depends on how many partitions you have. So let's assume you have 4 partitions and you have 4 consumers. So where is that data? Let me go back to that picture. Sorry guys, I'm taking so much time, but just give me like I can complete it in next 10 minutes. So where is that? Yeah, Kafka architecture. So as you can see, we have 4 partitions and we have 4 consumers. So let's take this particular example. So let's assume our consumer 3 is the one which is reading on partition 0 and the data is in partition 0. So let's say this consumer fails. So what happens is for this particular the offset is actually calculated for consumer group and not an individual consumer. So that is something which you have to take in mind. So here entire consumer group B is one big consumer, but within that for each partition you have 4 different consumers. But let's say consumer 3 fails, then the same message, depending on how the broker takes it, it might be consumed by consumer 4 also. So at that time, what happens? Consumer 4 will go to partition 0, and consumer 3 will take some other partition. So even this mapping is not always constant. Depending on the load and availability, this mapping also internally it will change within the application. So if it is failing in one consumer, the same might be picked up in a different consumer. And most of the case, what happens is in real time scenario, let's say consumer 3 has failed. So it will continue to read the same message again and again if it is auto. I think that is what the question was actually. So until and unless you start and stop the app, right? Or you do something in which you change the partitions assigned to individual consumer. Usually that's by restart, right? It will continue. That particular consumer will continue to read the same message over and over again. So this is another reason why we do not use auto commit. We have to use a manual commit, and this is one of the reasons. So I think that was a very good question. Are you talking about using Kafka as a system of recurrence of message-oriented? I'm not sure what is your question, Edward. Okay. If in batch one message faulty, how will the batch? Yeah, it's the same there also. How can batch with complete? So it's the same there as well. So whenever it comes to batch message listener, if something fails, that entire thing is redone again. So let's say out of the 30 records, 9 is committed back. So it will continue to read the rest 21 again and again. So that is another disadvantage when you're working with Mule and you have very less record. We do not actually recommend batch message listener. So that is something which will go through the design considerations. So moving on. Okay. So now let's consider a scenario where you have a batch or some sort of consumers, right? So there is a lot of data which is already stored in Kafka. So let's assume 1 million records are there, and you do not want to process it. So for some reason, there was some performance testing where they have pumped the system with so much of data, and you don't want your consumer to read all those particular offsets. So in that case, what we can do is we can set the latest commit of the particular consumer group to a whatever offset we know. So let's assume we have 150 messages, and your offset is at 100. Okay, and for some reason you don't want to read the next 50 messages. So what we can do is we can just we can do a seek operation where we have to specify the topic, the partition, and the offset. So once you give the offset, right, the latest offset of that particular consumer group will be set to that particular offset. So let's say you don't want to read 150 messages, right? In that case, you just come here and give the offset as 150. For this particular consumer group, it will start reading from the 151st offset. So this is something, it's kind of queue, like queue purging, I would say. So let's assume that there is no purge operation, right? So you don't know, there are some faulty messages which for some reason you have not given an error handling, right? So you want to escape those messages. In that case, what you can do, you can seek the offset which you fit is the correct one. And this can also be done from the UI part. But if it is something which you have to do from the code, if you have a custom logic for the code, we will just see that. So currently, all the messages here in the batch message listener, it's exhausted, right? So it's not actually picking up any messages. Now what I will do is I will set the offset to 120, or let me not do that. I'll just operation. Okay, we'll just do a seek operation. We'll see where it goes. So I'm just committing a seek, doing a seek operation. So now I have made a seek. You saw that immediately the batch message listener it polled for messages. So how much ever messages were there, I set the seek to 98. So whatever is after 98, it is treated as not read messages. So it is reading from the offset 99. Okay, so we'll just see how many it's consuming. Okay, we will get an idea of what are the total number of offsets we have. As you can see, we have set it back. So totally we have 130 messages, right? We set the offset to 98, so it has read 32 messages. So hope you guys got what seek does. Seek is basically like you can set the what offset it has to read from. It is basically used when you have to skip data, or whenever you want to read the same data again for some reason, or when you have to process the same data over and over again. Seek can be pretty much beneficial. So before we go on to consume, are there any questions? Okay, no problem, Eduardo. Any other questions, guys? We are at the end of, we have a last part of the demo basically. Okay, we'll go to consume operation. So for that, I need to redeploy the app. Sorry, so it will take some time. So I'll just toggle command this flow. Basically, I'm reading from the same topic again. I'm just untoggling this. Let me add a breakpoint. Okay, so I will deploy the app. Meanwhile, we can actually go ahead with the design consideration. I don't want to waste your time. Debug. So let this run. Chat. All right. No problem. Okay. So yeah, design consideration. So let me go to slideshow mode. So here I'm kind of limited to whatever was my experience with designing or coding for these solutions, right? Connector configuration. So as I told, there is a lot of configurations, especially in the advanced tab, when you are going to do is use a batch message listener or a listener. So that is something you have to configure properly depending on the size of the data and the volume of the data. So you have to carefully test out the scenarios where the configuration is working perfectly for whatever is the requirement. So this is something which you cannot predetermine. This has to be tested because in local it works differently, in cloud up it works differently because the heap, which is the worker size, and the latency between the cloud hub and the actual Kafka instance, all of these things come into picture. So the configuration properties, this is something which you have to do very carefully. Flow design. So why I put flow design is sometimes people will go with immediate or auto mode. So you should not go with immediate or auto mode. You have to go with a manual commit. So whenever you have a manual commit, you can design a flow in such a way that only if it is properly executed, you will process the message completely. Else, you cannot, you'll just reprocess the message. So a lot of options will open up when you have a manual commit. So whenever you are doing a manual commit or auto commit, regardless of that, whenever you have an error handling, you can have a manual commit in your error handling so that the same message is not read again. So this is something which you have to take during error handling and flow design. This is something which you have to take into consideration. Transformations. So usually when we use Kafka, it's in hundreds of thousands of records. If it is lesser than that, there is no ROI where you can find some valid use to use Kafka. Although you can use it for lower volumes, but whenever the volumes are in hundreds of thousands or millions of records, that's when we are actually using a transformation. I'm sorry, Kafka, right? So transformation, I would limit it. I would not transform the message until and unless it's actually required. Okay, because we found this. So if there was a lot of transformation, of course it will take up a lot of threads for individual transformations, right? And Kafka, it's like one-on-one, it will continuously hit your workers. So avoid transformations wherever is not required. That's what I'm trying to do. Topic management. So one disadvantage of this topic is whenever you create a topic, the number of partition, replication factor, and also the data retention period. These are some things which you cannot change. So based on the income, based on our particular what to say design consideration and requirements, right? We have to select the topics correctly. Okay, so that is something which the creation of topics is something which we have to think based on the volume, and that can be done only once. If you want to do it again, you will just lose all data. As far as I understand, if you want to recreate a topic, you cannot purge a topic. If you have to change its properties, you have to delete and recreate the topic with the same name again, which is something is a lot of operational overhead. Consumer group management. Okay, so lot of the times consumer group, if you do not specify a consumer group a name, it will give some random names in the UI. So I would always suggest that the consumer group name should be unique. So let's say you have one topic and each topic is considered configured by three different APIs. All those each individual APIs can have one consumer group name, so that in the UI part you can actually know which consumer is where. Okay, and the number of consumers should always match the number of partitions. So if you have a three partition topic and you have one API, the ideal recommendation is three workers. Even though you can go with less or more, more is waste of resources. Less, you are higher chances of hitting the usage limits of that particular application, depending on how high your volume is. Offset management, so you can seek the offset as we did in our in the code, right? So offset management is something which you can do when when you want to skip the data for that particular consumer operation. Mule workers, so as I said, it should be equal to the number of partitions. Logging, and if there is a lot of data which you are basically uh, expecting in your particular application, limit the logging, I would say. So don't log the payload. Logging, you can only just log the start and end of the flow, probably with the individual ID. So let's say you have a, so let's say you're working with Salesforce for some reason and you have Salesforce ID. You can say that the process has started for so and so process ID, and it has also ended. So only you can limit the number of logs, because if the volume is high, logging also it will take some computing time, right? So, and do not log the payload until and unless it's absolutely necessary, because you can already, if you know the what is the offset, and if you know what is the offset and partition of that particular message, you can always go back and see what is the content of it for debugging purposes. So there is no point in logging the payload until and unless it's absolutely necessary. So, are there any questions? If an app with the same listening to a topic with one partition is deployed on 10 multi-workers, how the message will be consumed? Okay, in that case, what happens is either any one of the worker will be active, rest are all redundant. So that might change. So it might listen from worker zero for some time, then it will switch to worker one to worker two. Because you have one partition, right? So even that will kind of fluctuate. But at a time, only one worker can read from a particular partition. Now, like it cannot read from two workers cannot read from one partition. So that's how it works basically. How can you validate the message to UI? So for that, probably I can show you a screenshot, but I don't think it's possible because Amazon AMSK is kind of uh, what to say. It's paid, right? So I don't think I can find any screenshots also. But basically, you can see the message, what message is being written. If you have not encoded it, if it is plain JSON or plain XML or plain text, right? And why in Amazon MSK, it usually converts the data into text. It stringifies the JSON, and then it uses for all those reading and writing things. So you can actually see the data, or you can download the data and you can transform it. So from the UI part, sorry, I cannot basically do it. So once it's consumed, how can you validate? You said do not log. No, I mean you have an end logger, right? You have a start logger and end logger. So from the end logger, you can know that in that logger, you can also log the offset of the message or the key of the message. So you also have a key. So from the key, you can just filter the data in the UI and you can see the message. And that's just it's a suggestion, but if the requirement is that you have to log it, you can log it, but it will take a lot of resources. Hope I covered your answer, Rahul. So let's go back to our demo, and this is the last part. So what I will do is I will just hit the consume. So let me trigger the consume. So here I am actually trying to consume message from the singular message. What to say? The single message topic, which is basically just the meter. So let us wait. Most probably it should fail with the Kafka not found error because there are no messages. So and even for this consume operation, you can actually have the consumption timeout and also the acknowledgement mode. Even here it's the same thing all over again. See, if no message was found. So close this. Let me trigger it once more, and immediately I will trigger a message into a single topic. So let's see if you will get a message now. Yeah, we got the message. You guys saw that, right? So here you cannot see the message because it's encoded, but let me add a breakpoint and try once more. We'll see what is the data there. So I'll consume it. Meanwhile, I'll just trigger it data. I'm just publishing one data. So I can see what is the payload. Hello, Meta folks. So this is the message which I sent, right? So this is consume operation is basically used whenever you don't want it to automatically trigger, but only the consume the messages only in the case where you need to consume it. You know, so that is one good thing actually here. So I am done with the demo, and I think we also covered all the design considerations. So I'm actually done with the demo. So if there is any questions, we can continue. Else, what do you want to know? Sham Vandana, are you guys there?
Thanks for the session. It was refreshing session for me. Like I've used Kafka 6 years back.
Nice. So anything you changed from 6 years, would you say? Or is it
I
basically?
have not used in MuleSoft. I have used
Oh,
in
okay.
Spring application. Yeah.
Okay. Okay. Okay.
Thank you.
So